Hello everyone. So in this video, we will talk about the Pythagorean cosmogony and the idea that things are composed of numbers, and how are things composed of numbers? How do numbers then go on to form solid bodies? And then the kind of cosmogony that they actually end up developing out of this. So we have Aristotle complaining about it in his Metaphysics, where he says that the Pythagoreans share the belief that there is one number, the mathematical, but they deny that it is separable and assert rather that perceptible substances are composed from it. For them, the entire universe is constructed from numbers, and there appears, however, to be no explanation in their theory of how the first one comes to have magnitude, right? And they have this sort of strange idea, according to Aristotle, that all solid bodies are composed of numbers. But for Aristotle, who had a very sort of physicist kind of approach to things, this is fairly bizarre. And Plato as well, whom he's trying to oppose, developed on this Pythagorean idea with his theory of forms, and Aristotle is not very happy about it. He complains about them again, throughout the book he's complaining about them actually. So you have another one where he says that the Pythagoreans, on the one hand, by not making numbers separable, they avoid many impossible consequences, true, but on the other, it is not on to have bodies composed of numbers and this number be mathematical. Sorry, this translation is a very modern one, I think. So it is not on, right, to have this, to have bodies composed of numbers and numbers be mathematical. It is, in the first place, false to introduce atomic magnitudes, and anyway, even if we could have such magnitudes, still units would not have magnitude. And how can magnitude possibly be composed of indivisibles? We'll talk about sort of atomism as well. He's mixing with the Pythagoreanism out here, and the Pythagorean theory of number, Pythagorean number atomism, which we'll discuss very, very briefly. But obviously, arithmetical number is unitary. The Pythagoreans, however, say that number is the entities, or at least in applying their theorems, they say they treat bodies as composed of those numbers, right? So that's another complaint from Aristotle. And moving on from that, what we have with Aristotle's view of the Pythagoreans is that all things consist of numbers, as we said earlier, and that in the literal sense, physical bodies are composed of numbers, which means that number, as far as Aristotle is concerned, is the matter out of which everything is composed, which Aristotle is not very happy with, because he was okay with the separability. Okay, he said there are problems with Plato and separability, but at least you have like matter as different from form. So numbers to be seen as a formal cause rather than a material cause, he doesn't have that much of a problem with. But here, what he's saying is that the Pythagoreans are odd enough to believe that number itself is a material cause, which means number is a matter of things, right? And in that sense, you know, when they talk about unity or limit or all of these things, these are not predicates, these are not qualities of objects. Like, it does not say, we are not saying that this cup is one and it is finite, or, you know, the universe is infinite, which would be a way of thinking about this in terms of predicates, but rather that the number one, or finitude or infinity, are themselves substances which form the basic element of everything else, right? So what he's saying is that for the Pythagoreans, physical bodies are constructed out of these abstractions, you know, these things which should be abstract things, separable conceptually. But for the Pythagoreans, physical objects are composed of these abstractions, and so he would say that they confuse the material and formal causes. And their arche, as far as Aristotle is concerned, is something entirely formal, which he says doesn't make sense, right? So when they're describing the structural nature of things, they believe that they are describing the material nature too, right? So that is the problem with arche being a formal thing, like numbers. For Aristotle, numbers are entirely formal. They don't have any substance to them. So he says that, you know, they think that they are describing, you know, substance when they're actually just describing structure. Which he says doesn't make sense. You know, when you're talking about, you know, the structure of something as being cuboid, you know, you're not going to say that the cube is the matter of it. You know, it's the substance itself is that, Right? So, but today, actually this makes a kind of prescient sense, because the scientific description of everything, if you notice, in the physical world is in terms of numerical equations, and most fields are moving towards a kind of mathematical ontology, are moving towards this idea that everything is composed of, mathematical entities, of numbers in that sense. And what we see as physical qualities, what we see as color, we see as heat, light, sound, all of these are in fact wavelengths and wavelengths and masses themselves are not exactly physical entities per se, but they're more of sort of mathematical entities, right? But yeah, moving back from there to to the time when they were talking and they were not really thinking in these really complex terms that we have right now. What is meant by the generation of things from numbers, right? So we talked in the last video about the limit and the unlimited and the odd and even and the unit, and the idea is that these sort of notions of numbers actually give rise to actual numbers. And these numbers then, there's a logical priority rather, these numbers then give rise to geometrical figures. So for example, the number 1, the unit, is a point, right? The number 2 is a line, right? It has 2 points in that sense. The number 2 is a line, and then number 3 would maybe be a triangle, in some cases a square, I don't know, but mostly a triangle, I would say. Then the number 4 would be a square, and so on, right? So they give rise to geometrical figures, plane geometrical figures. The plane geometrical figures then can give rise to geometrical solids, and these geometrical solids are what compose physical objects, which is why when they talk about physical objects, they say that they are composed of numbers, right? Because they are composed essentially of these different sort of numbers from units and 2s and 3s and 4s, and so really we are moving from a number theory or just numbers as they understood it to plane geometry, to solid geometry, to the physical world, right? So the unit then can be considered as the arche, or the beginning of the number series. It is, as we saw, it is both odd and even according to Aristotle, which in their turn are aspects of the limit and the unlimited respectively, as we also saw in the previous one. And we looked at the field of music, where you have an unlimited continuum of sound, and the limit is imposed on this continuum by numbers, right? So 1:2 makes an octave. 2:3 makes a fifth. 3:4 makes a fourth, right? So we then have all this, and in fact, it's very interesting, because then once you do that, if you add a fifth to a fourth, what will you get? So you will get I think a 9/8 or something, and so you will get what is thought of as a tone. And in fact, I'll see if I can share some text about this with you. They started thinking of terms like of music in terms of the 12-tone system, the well-tempered 12-tone system, in which what is the unit of the musical sort of entity. So the limits that are placed that would make it into a sort of a musical scale with na, 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 na. That's a diatonic scale. The chromatic scale I'll do separately. But the idea that the musical scale. Idea of a musical scale and the idea of the units that are composed, and how do you temper it to have, and what is the minimum unit, what is a tone, what is a semitone. So the idea of a tone or a semitone was something that the Pythagoreans had already they had discovered, and they were actually working on it, and this was like central to their theory, right? So the unlimited, to go back to our mathematics, is thus contained or confined within the order, within the cosmos, by the imposition of a limit or a measure, right? The measure, the limit, the ratio sort of limits the unlimited continuum by making it discrete. And so they're actually really seriously thinking about the dialectic of the continuous and the discrete, which will be extremely important in the history of philosophy and in the history of ancient philosophy. We'll see in the next few people that we'll cover, whether it's Zeno's paradoxes, or it's an Anaxagoras, or it is the Atomus, or Empedocles even, we have a very strong sort of question of, the unlimitedness of space and the limitedness of phenomena, and of thinking space and time in terms of continuity and discretion, right? Is space-time continuous, or is it composed of discrete units? And this will lead to the question of infinite divisibility versus divisibility. And you can see these questions have already arisen with the Pythagoreans, right? So you have with Pythagoreans a sort of dualism out here in the account of ultimate principles of the limit and unlimited, but you also have a kind of pluralism which comes out of this dualism, because the whole physical phenomena comes out of it. But underlying it, one can argue that there's also a monism, because there's the ultimate one from which the whole limit and unlimited are derived. So it's very difficult to place them in a box, to say, well, are they monist? Well, not quite, because they seem to be dualist, but are they just dualist, but they are also monist and also pluralist? So putting them inside a box is very difficult, right? The arche, again, is very difficult. So one idea of the arche is that it is the unit, the one. One idea of the arche is that it is this dual principles of limit and unlimited. So the arche is difficult. The telos, however, is very clear, right? The telos is the cosmos. It's the good order. It's the limited. It's the unity that we have at the end. So perhaps if we want to push them into the Milesian mold, we can say they are monist in the sense that the originality is the unit, and the arche and the telos being one and the same are the sort of completed, limited, unified cosmos. But yeah, we don't know, right? So. To move on from the question of arche to, I got a bit distracted. So when we are looking at the composition of solid objects from units, so what we have is that we have this idea of points, as I said, as unit, lines as two, planes. So we go from points to lines to planes to surfaces to solid bodies to physical objects, right? So a point is the action of what they would say, the action of the limit on the unlimited. So the point could have extended forever. How do you form a point? By placing a limit and saying this one without magnitude, or with the magnitude of a unit, is a point. And that's what is causing confusion everywhere. If the point has no magnitude, does it have magnitude? And later, Zeno's paradox, which we'll see, is probably answering this question directly. Does the point have magnitude, or does it not have magnitude? If it has magnitude, then it is infinitely big. If it doesn't have magnitude, then it has no size. Okay. Anyway, we'll cover Zeno's paradox when we do Zeno. So you have the point. By the action of the limit on the unlimited, you will get the point. Now the point can become a line by 2 points. If you place 2 points and you draw the distance between them, you will get a line, right? So you're placing 2 limits. Again, by placing 2 limits on this line could have gone on forever, right? But you place 2 limits, so then you got the number 2 and you got a line. So that's the next placing of a limit on an unlimited. Then you got 3 limits. Now these could have gone on endlessly, but the 3 cross each other, and at some point that places the limit, and that limit then gives you a triangle, right? And then so you're moving from a point to a line to a plane, right, to a surface, to you can go from a triangle to a pyramid, in which you have 3 points like this, but you place 1 point out here, and then you immediately get a 3-dimensional space, right? And so the pyramid is a number 4. And remember, we talked in the last video about the importance of the number 4. So the whole physical world can be created by just thinking of these 4 numbers: the unit, the line, the plane, and the solid, right? 1, 2, 3, 4, right? Or you can think of it as 0 dimension, 1 dimension, 2 dimensions, 3 dimensions. So you have four ways of thinking about it, right? Point, no dimensions, as the Pythagoreans think. Line, one, single dimension in that sense, plane surface, 2 dimensions, and the solid surface, 3 dimensions. So they're doing a kind of topology out here of like they're placing it in the world, and they're moving towards this idea of everything contained within sort of these 4. Right, the number 4 contains everything. So this unity then would then be a non-dimensional point. Yeah, and the dimension is how do we understand dimension for the Pythagoreans? I'm using this term sort of as if it's explained. It's that which is conceived as being between limits. Right, so the unit is when the limit is placed so early that it has no time to sort of go in any direction, right? So it becomes a non-dimensional thing. The limit is the only thing in the unit or the point. Then you have the line, which then goes to like the limit is placed between 2 limits. You have the first dimension. 1 dimension comes when you have 2 limits, right? Limits on both ends. 2 dimensions come when you have 3 limits. 3 dimensions come when you have 4 limits, right? So that's how they would think of as the 4 numbers. Then later Pythagoreans actually came up with something called a Fluxion Theory, which is actually very fascinating, which is the idea of a self-moving number, right? So the point is the number 1, let's say, and that is still, it's not moving. That's why it's in one place. Now, when the point fluctuates, if the point will fluctuate, it will go from one place to another. So the fluctuation of the point, the fluxion of the point, will give you a line, which will give you the number 2. Then the fluctuation of the line will give you the number, well, will give you the square, because you have the line and it fluctuates from both ends. You'll get a square, which will give you a plane surface, which will give you the number 4, I suppose. And then the fluctuation of the square will give you the number 8, which is the cube, right? But this is probably Neo-Pythagorean. This is not Pythagorean. Most people sort of believe that this Fluxion theory came much later. The original, which went from point to line to triangle to pyramid, was the original Pythagorean theory, right? So the idea is here, and I'll just read it out, is line is the fluxion of a point. The moving line generates a surface and then a solid. And so we imagine the line, which is length without breadth, as the flowing of a point, and breadth, that is the surface without depth, as the flowing of a line. And by the flowing of a surface, a body is generated. So this we have from Sextus. So how is the body generated? Through the fluxion of the point, right? So the point in that sense is a real arche, right? So the point, by the fluxion of the point, the flowing of the point, we generate a line. By the flowing of the line, we generate a square. By the flowing of the square, we generate a cube, right? So first we have like point, which has neither length nor breadth. Then we have line, which has length and breadth. Length without breadth, line. Then you have the square, which is length and breadth. And then you have cube, which is length, breadth, and depth, right? So you have 3 elements. So again, you're going from 1, 2, 3, 4, actually, not to 1, 2, 4, 8. But yeah, the Pythagoreans did have a tendency to confuse other people because so many people said so many things. So now that we have solid figures, either the cone, like the pyramid, or the cube, right, whichever we have, from this then we can form sensible bodies, right? And then they had all these theories of the earth being formed of cubes. Earth has cubes, fire being formed of pyramids, perhaps because it's pointy and sharp, hurts, so maybe that's why it's formed of pyramids. Air was an octahedron, water was an icosahedron, so 20 sides, 20 sides, and the sphere is a dodecahedron with 12 sides, or 12 pentagons sometimes, so 60 sides. So you have, and you have this fellow Eurytus, who basically, tried to create these figures of man and horse by putting pebbles. And this is probably just again a story. We don't really know whether he existed, one of the Pythagoreans. So he put the number of pebbles, and he said that the number of human beings was the number 250 or something. I forgot, 248, 250. He came up with some sort of strange ideas. But you see how everything then gets composed of numbers. All sensible bodies then get composed of numbers. And I think even now, I remember coming across an article in which somebody said, oh, the Pythagorean idea was correct. Water is actually an icosahedron. And so this is something that was, that they had, how had they discovered? I don't know. I mean, maybe they were just coming up with things. The essential difference, though, between different kinds of bodies lay in this harmonia, this joining, or even this logos, this measure, in which the elements were blended. Yeah, and the elements themselves were put together from mathematically defined figures. You have these mathematically defined figures from which the elements were put together. So when they say that the whole universe is a harmonia and a number, when the whole universe is a harmony and a number, what they mean is that it's a joining together of numerical sort of objects to form the world, the cosmos. And the whole cosmos then can be explained via numerical objects. And you see why they wanted to kick out the unlimited and the irrational. Unfortunately, they were stuck with it, right? Because even when they tried with the basic triangle to figure out the length of the hypotenuse, they ended up with √2, and they were like, oh no, no limit. How do we do this? And that's why they didn't like even numbers, I think. So, and this placing of the limit makes the cosmos something that is a good thing, because then it sort of is structured, is understandable, is comprehensible, and elements that are not mixed in proportion and which are unlimited and without limits. It's chaos, evil, ugliness. They didn't like all that, right? So before we sort of go further, I want to just sort of very shortly, briefly, talk about this idea of number atomism that you have with the Pythagoreans, in which, or maybe I'll talk about it in the next video. So let me sort of stop this one about the composition of solid objects, and we'll talk about number atomism in one video, and then in another video we'll talk about their cosmology and harmony of the spheres very shortly, very briefly, and then that will be it for the Pythagoreans. Thank you.